Okay, today we're going to talk about comparing two populations or groups when it comes to their proportion of successes. And we're first going to talk about what would the sampling distribution of a difference between proportions look like. So say we have two populations. In population 1, we take a simple random sample of size n, size n1 because it's population 1, and p1 is the proportion of successes within the population. And then we have population 2, we take a simple random sample of size n2, and p2 is the proportion of successes. Okay. Then the sampling distribution of p hat 1 minus p hat 2 will be shape. It will be approximately normal if n1 p1 n1 1 minus p1 n2 p2 and n2 1 minus p2 are all greater than or equal to 10. So that's the large counts condition. The large counts condition, it has to be met in both populations. And then we can say that the shape will be approximately normal. The center. Right. Well, if we're going to subtract two things, the mean of the sampling distribution of p hat 1 minus p hat 2 is just p1 minus p2. And the spread and the standard deviation or also referred to as the standard error is the square root of p1 times 1 minus p1 divided by n1 plus p2 times 1 minus p2 divided by n2, as long as the 10% condition is met for both populations. Okay, so we really haven't learned much new here. I said if we're going to look at a difference between two populations, then we have to make sure that the conditions are met for both populations. That's really a lot of what we learned here just in this little bit. Okay, so let's look at an example. American-made cars. Nathan and Kyle both work for the Department of Motor Vehicles, but they live in different states. In Nathan's states, 80% of registered cars are made by American manufacturers. In Kyle's state, only 60% of the registered cars are made by American manufacturers. Nathan selects a random sample of 100 cars in his state, and Kyle selects a random sample of 70 cars in his state. Let p sub n, p hat sub n minus p hat sub k be the difference in the sample proportion of cars made by American manufacturers. What is the shape of the sampling distribution of p hat 1 minus p hat n minus p hat k? Okay, so our solution. We're going to do our solution for A. Well, since he had n, so Nathan's state, it's 100 cars in his state times 0.8 equals 80, and 100 times 1 minus 0.8 equals 20, and then from Kyle's state he had a n2, so this is n1 p1, and N1, 1 minus P1, and then 70 times 0.6 is 42, and 70 times 1 minus 0.6 is 28. All are greater than or equal to 10. The distribution is approximately normal. So again, just the large counts condition, but it's done for both populations. Solution B. The mean of is just going to be 0.8 minus 0.6, which is 0.2. Just subtract the two proportions. C. It's safe to assume there are more than 10 times 100 or 1,000 cars in Nathan State, and 10 times 70 or 700, more than 700 cars in Kyle State. So it should be more than. Standard deviation would be the square root of 0.8 times 1 minus 0.8 divided by 100 plus 0.6 times 1 minus 0.6 divided by 70, and that turns out to be 0.0709. Okay. So that's all we're really asked to do, to talk about shape, center, and spread of the sampling distribution of the difference between proportions. Next we'll move on to making a confidence interval for those as well.